In the previous lecture, I have discussed about the traffic characteristics, primarily on the road user characteristics as well as the vehicular characteristics. Next is the traffic stream parameters. Okay, so basically the traffic stream parameters, the main purpose behind them is to get the knowledge of the nature of traffic as well as certain forecasting process also. So basically in the traffic engineering, the primary part is to analyze the behavior of traffic and to design the facilities further for a smooth as well as safe and economic operation. Okay, so for this, these are the certain parameters that needs to be analyzed. Speed of the traffic stream, that is the speed of the vehicles, then traffic volume or traffic flow, then density of the traffic and headway. So these terminologies will come many times during the discussion. So basically in the traffic stream parameters, the traffic stream includes a combination of driver as well as the vehicle behavior. So the driver or the human behavior, these are here also like in the traffic stream are non-uniform. It varies, as in the previous lectures we have discussed. So basically here the purpose of planning and design, these values needs to be evaluated. So now talk about the speed. Okay, so speed is basically, it is the rate of motion in say distance travelled per unit time. So mathematically the speed or velocity is given by, that is the distance travelled with respect to time in meter per second, basically the unit is. So speed of different vehicles may vary with respect to time and with respect to space. So here space is basically means the actual speed of different vehicles over a particular route depends on several factors. The speed of each vehicle, it may fluctuate depending on say geometric features of the road, traffic regulation control, then the traffic volume on that stretches, time of travel or the purpose of trip, then climatic factor as well as certain environmental factors also, then type of vehicle, characteristic of the driver. So there are various conditions on which the speed of each vehicle depend. Okay, so to represent this variation, several types of speed can be defined. So among them, certain type of speed has been considered which is used for the design purpose. That is some of the commonly termed speed, that is basically the time mean speed, or it is called the spot speed. So spot speed is basically the instantaneous speed of a vehicle at a specified cross section or a location. Means the spot speed of a vehicle fluctuate from place to place along the route depending on various factors indicated above. So now how to calculate the time mean speed? So time mean speed is basically, it is also an instantaneous speed, okay, at a particular point, but it is basically the average speed of all the vehicles passing a point, a particular point on a highway over some specific time period. So and another thing is the space mean speed. Space mean speed, it is the average speed of all the vehicles but occupying a given section of highway, okay, over some time period. So the basic difference in between them is, it is particular a point or a location, where space mean speed have to be calculated over a certain stretch, a section of a highway. In that section, how many vehicles are coming, and based on that, as per the count of the vehicle, the speed is evaluated. Okay, so both the mean speed, it will always be different from each other. Okay, the time mean speed is a point measurement, while space mean speed is a measure relating to the length of a highway or a lane. So the time mean speed, so here it is evaluated by using, say, a radar speed meter, where at a particular location, say a vehicle is coming, a radar light will fall on that and it will tell about the speed of that particular vehicle on a particular spot. So basically the spot speed or the instantaneous speed, it can be used to design the geometry of road, like horizontal and vertical curve, then location and size of the signboards, even the design of signals, safe speed. Okay, so for this they require the spot speed data. So how the calculation is, that I have earlier told, it is a summation of, that is the average speed at a particular point with respect to the number of vehicles that have crossed. Means suppose this is the point, and at this point whatever vehicles are crossing, you can calculate the speed. So you are calculating the speed at a particular instantaneous point itself, not a particular stretch. So suppose many times in the cities you have seen that there is a speed overshowing, that whenever you cross the limit of the speed, then some fine may also be imposed to you. So many people do that they slow the speed at a particular point. Okay, so that's why basically at a particular point, whatever the speed of the vehicle is calculated using the time mean speed. And the space mean speed, so space mean speed, it is obtained from the observed travel time of the vehicles over a stretch of road. Okay, next is spacing. So spacing is also similar to the headway, that is the initial I have discussed about. So it is basically the distance between the two corresponding points of two successive vehicles at a given time. Okay, so that is the between the two vehicles, what is the distance, a front bumper to front bumper, that is basically the spacing between two vehicles. So after your speed, that is your distance traveled with respect to time, the next important factor is density. Okay, so as per the diagram, density is basically the number of vehicles occupying a given length of highway. Suppose this is my length, consider suppose 1 kilometer of stretch I am having. So how much number of vehicles are there in that 1 kilometer stretch, that is basically the density, means vehicles per kilometer. Okay, so basically one can photograph a length of road, say S, and count the number of vehicles in between them and derive that number of vehicles within that stretch, that is vehicles per kilometer. So next one more topic is there, that is based on the speed, that is the spot speed study, certain calculations are there. Okay, means why you require that spot speed I have earlier told, but here means how you present that spot speed data, that is also important. So from the spot speed data of a selected sample, so you have to do a frequency distribution table. Suppose you have gathered 100 vehicles data. So 100 vehicles are having different speed. So you have to first differentiate like a speed group. Suppose 10 to 20 kilometer, 20 to 30 kilometer, 30 to 40 kilometer, and you have to count that within that speed range how many vehicles are present. Like suppose out of 100 vehicles, in the range of 10 to 20 you have 5 vehicles, 20 to 30 you have 10 vehicles. So you can distribute in that manner, and the number of vehicles in each speed range you have to count. Okay, then you have to calculate the arithmetic mean of the measured speed. Okay, so after getting the speed value for a particular range, you can distribute it in terms of percentage. Suppose there are 5 vehicles in the speed range of 10 to 20, so then its percentage is 5 by 100. Okay, means total counting is 100 vehicles and 5% of the vehicles is in that speed range. Then 10, so 10% of vehicles are in that speed range of 20 to 30. Then for 30 to 40 there is another percentages of vehicles, and at last you have to do another table, that is a cumulative frequency, and that cumulative frequency will count it as further 100. Okay, that counting from that 5 plus 10, 15, 15 plus then another cycle. So you have to plot it, the graph, in this manner, in the cumulative percentage, that is a cumulative speed and the speed ranges. Okay, and this graph is called the cumulative speed distribution diagram. Okay, so here from the diagram, suppose there is a speed 85th percentage. Okay, so here is certain 98, 85, 15. So these are the percentages which are considered for the design. So different percentages are having a different function. So suppose 85 percentage. So from the diagram we can see the 85th percentile speed. You can determine from this point, this is my speed V85, that is the 85th percentile speed. So it means that the speed at or below the 85% of the vehicles, or below that speed, 85% of the vehicles are passing the point on the highway. Or in other words, we can say that 15% of vehicles exceed this speed. Suppose that speed value comes 50 kilometer, okay, 50 kilometer per hour, that speed value we get. So we can say that 15% of the vehicles are crossing that speed. Okay, so exceeding that speed, or crossing that speed means exceeding that speed. So the drivers exceeding the 85th percentile speed are usually considered to drive faster than the safe speed under the existing conditions. So you can see the board are given, that is the what is the safe speed or what is the design speed there. So that means that percentages of the vehicles are exceeding the safe speed. Therefore, if a speed limit regulation sign is to be installed in an accident prone location or any other critical location like nearby hospitals also, so spot speed studies and the 15 percentile speed, basically the 15 percentile speed are used to establish the typical walking speed for traffic signal timing. Okay, and 85 percentile speed is used to set the speed limit, while the 98 percentile speed, okay, so basically for the purpose of checking the requirement of highway geometric design, the 98 percentile speed is generally taken as the design speed of the existing roadway. So this is considered as the design speed, this is considered as the safe speed, and this is the speed considered for the pedestrian movement or the typical walking speed for traffic signal timing. So the calculation for 3 different speed is vital. Another factor is the traffic volume or traffic flow. So speed is basically distance traveled with respect to time. Okay, then I have discussed the density, it is vehicles per kilometer. Then comes the volume, so volume is vehicles per hour. means at a particular time. So it is basically defined as the number of vehicles that pass a point on a highway or a given say lane during a specific time interval. Suppose you have done it in 15 minute in counting. So you have to simply convert it into 1 hour. So basically its measurement comes that number of say vehicles per hour. So the variation of volume with time as well as it occurs from month to month, day to day, hour to hour, the variation occurs means number of vehicles at a particular time. So suppose during our college timing hours, the number of vehicles obviously will be more during the 9:30 to 10:30 time as well as from the evening time. So the time to time the traffic volume varies. So as the volume variations, it can be observed from season to season also. Then the volume, it will be above the average in a monitoring month of summer. Okay, because in summer it has been observed that very few people move outside, but during the weekdays, Saturdays, Sundays, so a different pattern is observed. So there is a comparison day to day. Then the route, even in various route, the volume varies. The most significant variation is basically from hour to hour. So here the peak hour observed during the morning and the evening timing. So one more important thing is there, the peak hour. So later on I will discuss what is the peak hour here. So various types of volume measurements are there, but the common is that AADT, that is the average annual or the annual average daily traffic. Okay, so here the average 24-hour traffic volume at a given location over a complete 365 day in that year is calculated. That is the total number of vehicles passing a particular site in a year divided by 365. That is the average annual daily traffic. Then another is the ADT, that is the average daily traffic. So an average 24-hour traffic volume at a given location for some time period of less than a year. So it may be measured for 6 months, a month or a week, okay, or it can be say 2 day. Okay, so it is basically, it is a valid number for the period over which it was measured. So for that case, no yearly data needs to be considered. Next important thing is the peak hour volume, because for this the peak hour factor is being calculated. So basically the peak hour factor is the hourly volume during the maximum volume hour of the day divided by say 15-minute flow rate. So basically it means, suppose I have evaluated the traffic volume, that is the vehicles per hour, okay, so at a particular section, and I have found that is I have to calculate it in terms 15-minute interval, say at 4 o'clock, 4 to 4:15, 4:15 to 4:30, 4:30 to 4:45, and 4:45 to 5 o'clock. So for there are 4 consecutive point data I have selected. So suppose that in my initial time, that is 4 to 4:15, I have number of vehicles say 2000. Then 4:15 to 4:30 I have 4000. Then 4:30 to 4:45 I have suppose 3000, and 4:45 to 5 I have a vehicle data of around 2800 suppose. So on an average, what is my total count of the vehicles, okay, in that 1 hour duration? Suppose it is around 12,000 for example, divided by 4 into what is the maximum of that 4 time slot. So for this case 4000 would be the maximum time slot. So 4 into the 4000, that is the highest 15-minute volume, and what is the total volume for that particular 1 hour. So by this we can calculate the peak hour factor. So and that value, that whatever value you are getting, so that is used basically for the approximation of peak hour factor in terms, like if it is close to 1, that means suppose 0.95, 0.98, so it is basically for the congested conditions, while as the value getting reduces, so the congestion also decreases. It means to say that is for the rural road, that factor will be less, or for the major road the factor will be more, for minor type of road the factor will be less. So for different type of road also, then based on the condition of traffic, that factor varies.